Welcome back once again. In this section, we are going to discussing about the factors influencing the rate of the reaction or the factors affecting the rate of the reaction. The main factors are, the first factor is concentration of the reactants. There is a mistake, we correct it. Concentrations of the reactants. Second factor is nature of reactants and products. Third factor is temperature. The fourth one is pressure. Fifth one is catalyst. And the last one is presence of light or radiation. So these are the factors influencing the rate of a chemical reaction. Let's discuss one by one. The concentration of the reactants. If the concentration of the reactant is more or higher, the rate of the reaction is higher. More the reactant, very fastly the reaction going on. So concentration is important here. The next one is nature of reactants and products. How the nature affect the rate of a reaction? More reactive reactants will increase the rate of the reaction. If the reactants are more reactive, the reaction is very fastly takes place. Then an example രണ്ട് gentlemen collide. They just collide. What happens? Because they are gentlemen, they just say sorry. So there is no reaction. There is no reaction between the two persons. In another case, one gentleman and an aggressive man, they just collide. What happens? One man gets angry, other just says sorry. So one reactant is active, another is passive. In another case, two aggressive people just collide. What happens? You imagine that there is a big problem. So very fastly the reactants combines that give the product. So the nature of the reactant and product. If the product is unstable, what happens? In +1 we learned about the product decomposes gives reactants. So that's why we can say that nature of the reactant as well as product. Okay, are you clear? If the reactants are more reactive, the reaction occurs very fastly and therefore the rate of the reaction increases. And next is temperature. As we know that temperature increases, the kinetic energy of the molecule will increase. If the kinetic energy increases, they move very fastly. They collide very fastly. That collision leads to the chemical reaction. ഇപ്പോൾ രണ്ടുപേരും തമ്മിൽ അടി ഇല്ലെങ്കിൽ നമ്മൾ എന്ത് ചെയ്യും? നമ്മളൊന്ന് ചൂടാക്കി കൊടുക്കും. അപ്പൊ രണ്ടുപേരെ ചൂടാക്കി കൊടുത്താൽ അവിടെ അടി നടക്കും. അതേപോലെ റിയാക്ടൻസിനെ ചൂടാക്കി കൊടുക്കും. റിയാക്ടൻസിന് ടെമ്പറേച്ചർ സപ്ലൈ ചെയ്യും. By increasing the temperature 10 degree, the rate of the reaction is nearly double. 10 degree or 10 Kelvin. 10 degree Celsius അല്ലെങ്കിൽ 10 Kelvin temperature increase ചെയ്താൽ reaction rate nearly doubled എന്നാണ് പറയുന്നത്. ഏകദേശം 2 ടൈം ആയിട്ട് increase ചെയ്യും. So temperature is very important factor. Let us discuss detailing. Pressure. In the case of gaseous reactants, pressure is one of the important factor. Last class we discussed the instead of concentration we have to use partial pressures. The unit of rate constant is atm second inverse or barometer second inverse. If the gaseous reactants and product are involved in the reaction, pressure is an important factor. And fifth one is catalyst. What are catalysts? Catalysts are the substance which alter either increasing or decreasing the rate of the reaction without participating in a chemical reaction. ഒരു കെമിക്കൽ റിയാക്ഷനിൽ പാർട്ടിസിപ്പേറ്റ് ചെയ്യാതെ റിയാക്ഷന്റെ റേറ്റിനെ ഇൻക്രീസ് ചെയ്യോ ഡിക്രീസ് ചെയ്യുന്ന സബ്സ്റ്റൻസിനെയാണ് നമ്മൾ കാറ്റലിസ്റ്റ് എന്ന് പറയുന്നത്. അപ്പൊ കാറ്റലിസ്റ്റ് ഓൾസോ increase the rate of the reaction as we studied in +1. Catalysts bring the equilibrium very fastly. Catalysts do not affect the equilibrium constant, but catalysts bring the equilibrium very fastly. And the last one is presence of light or radiation. Some reactions occur in the presence of light only. For example, the formation of ozone in the atmosphere is occur in the presence of UV light. O2 plus O2 in the presence of UV becomes O3, and similarly the reaction is the decomposition of the O3 into O2 is also undergoing in the presence of UV light. But light in the presence of the reactions. I think we saw the bottles of medicines kept in dark and cool places or keep away from the light. Why? Because light initiates the decomposition of medicines, and that's why such medicines are kept in the dark brown bottles, and in the sticker there is a caption or notification kept in dark and cool places, not in refrigerator. It's just kept in the shelf. There is darkness and the cooling effect is there. So these are the factors which influencing the rate of reaction. Let us discuss one by one. The first factor, concentration of the reactants. Effect of concentration of the on the reaction rate. As we discussed just now, the concentration of reactants increases, the rate of the reaction increases. In +1, we learned about the law of mass action. What is law of mass action? Law of mass action states that the rate of the reaction is directly proportional to the product of molar concentration of the reactants. According to law of mass action, the rate of a chemical reaction is proportional to the product of molar concentration of the reactants. ഇത് നമ്മൾ +1 പഠിച്ചതാണ്. ഇക്വിലിബ്രിയത്തിൽ എടുത്തു നോക്കുക. കെമിക്കൽ ഇക്വിലിബ്രിയത്തിൽ റേറ്റ് ഓഫ് ഫോർവേഡ് റിയാക്ഷൻ, റേറ്റ് ഓഫ് ബാക്ക്വേർഡ് റിയാക്ഷൻ അവിടെ കൊടുത്തിട്ടുണ്ട്. യു ജസ്റ്റ് റിവൈസ് the same in the NCERT book from the +1 classes. So refer +1. So here again we consider a hypothetical reaction. A moles of A from +1. A moles of A plus B moles of B gives C moles of C plus D moles of D. What about the rate expression? The rate expression is proportional to rate of the reaction is proportional to product of molar concentration of the reactants. So rate is directly proportional to concentration is expressed in square bracket, as we know that. So proportional to concentration of A raised to X, B raised to Y. In +1 we noted A raised to A, B raised to B. Here a change. A raised to X, B raised to Y. And a condition is there where the exponents X and Y may or may not be equal to A and B. In some cases X is equal to A, in some cases X is not equal to A. Similarly, y is equal to b, maybe y is not equal to b. We will discuss later with the example. Okay, so the proportionality is changed into constant. We bring a constant to remove the proportionality. Rate is equal to k into concentration of a raised to x, b raised to y, where k is known as rate constant. K is known as rate constant. What is K? K is known as rate constant. Remember that. As earlier, in plus 1 capital K, it is equilibrium constant. Are you clear? Okay. Then we put a condition. If the concentration of A is 1 molar, the concentration of A is 1 molar and B is 1 molar, we can say that unimolar. Uni means 1. Then put the values in the above equation. Rate R is equal to K into, what is the concentration of A? 1 molar. What is the concentration of B? 1 molar. So 1 raised to X, 1 raised to Y. What is the final answer? Rate R is equal to K. This time become 1. So rate R is equal to K. Can you define the rate constant? Can you define the rate constant? Okay, I will define. Rate constant K is the rate of a reaction when unimolar concentration of reactants are taken. Rate constant K is defined as the rate of a reaction when unimolar means the concentration is 1. Unimolar concentration of reactants are taken. So that's the definition of K. Remember this equation. If the concentration of A and B are 1 unity, the rate becomes rate constant, or rate constant becomes rate. Next, we have to define the rate law from the above equation. Rate law from the above equation. What is rate law? Can you define the rate law from the equation? What is the equation? Rate R is equal to K into concentration of A raised to X, B raised to Y. Rate R is equal to K into A raised to X, B raised to Y. You just define this rate. Okay. Rate law is the expression. This is an expression in which reaction rate is given in terms of the rate of the reaction given in terms of molar concentration of the reactants, with each term raised to some power, which may or may not be same as the stoichiometric coefficients of the reacting species in a balanced chemical equation. The definition is given in your textbook. Anyway, I wrote on the board. Once again, I explain this. Rate law from the rate equation. Rate law is the expression in which the reaction rate is given in terms of molar concentration of reactants, with each term raised to some power. You can see that the power. The concentration of the reactants is raised to some power, which may or may not be. Sometime may be equal, sometime may not be equal. stoichiometric coefficient of the reactive species in a balanced chemical equation. This is a rate law. You just remember, you study this because in a question paper, as earlier, the question paper, 1 mark question is, I think, I don't know the year. 1 mark question is define rate law, state rate law. So 1 mark question, you just memorize this. Then we move to explain the rate law by taking some examples. Okay, the first example is 2 NO gas plus O2 gas gives 2 NO2 gas. The rate is equal to, here A is NO and B is O2. So rate is equal to K into NO raised to 2, O2 raised to 1. Here in this example, A and X are same. A is same as X. Y is same as B. So here X and Y are same as A and B. Another example. 2 N2O5 gas gives 4 NO2 gas plus O2 gas. Rate of the reaction K into N2O5 raised to 1. We expect 2, but not 2. It is 1. Experimentally determined, it is 1. So here X is not equal to A. A is 2 here, but X is not equal to A. Then the third example. In third example, CHCl3 chloroform, trichloromethane chloroform, react with the chlorine will give carbon tetrachloride or CCl4, pyrene, you studied in plus 1, plus HCl. The rate of the reaction is equal to, the rate is equal to K into concentration of CHCl3 raised to 1 and the concentration of Cl2 raised to half. We expected 1 here, but not 1. Experimentally it is determined that the power, the exponent is half. So what we can say that X is equal to A. X is equal to 1. That is A is also equal to 1. But Y is not equal to B. Y is different from the value of B. Okay, are you clear? Thank you.